Okay, question 8. We're told the equation of this curve here is being modelled by this y equals log 3.6x minus k. And we're asked to find the value of k. Alright, so we know that when x is 1, that y is 0. Which gives us 0 equals log 3.6x take away k. E to the 0 is 1, so 1 equals 3.6x take away k. Oh, sorry, I know that x is 1, sorry, so 1 equals 3.6 minus k, so k equals 2.6. Okay, so now having found k, we've got to find the depth of the swimming pool. So the depth of the swimming pool, we're trying to find when x equals 1.18, what does y equal? So we've got y equals log 3.6x take away k, which we now know is 2.6, which is 0.4996 meters deep. Okay, now find the depth of the pool. The pool is being filled with water from a tap, and we're asked to find, in terms of h, the volume of the water when it's filled to a depth of h. Okay, so the volume, we're going to effectively rotate this around, so it's pi integral of x squared dy. Okay, and x goes from h, the depth, to 0. So we've got to find what x squared is. So we've got y, so I do a little side over here, is log 3.6x take away 2.6. So e to the y gets rid of the log, plus 2.6 over 3.6 equals x. Okay, so we can use that over here. So it equals pi integral of e to the y 2.6 squared dy. Okay, so we'll expand that out, and we'll take the 3.6 squared out the front. Pi over 3.6 squared. Just do it on a calculator, but the integral between h and 0 of e to the 2y plus 5.2 e to the y plus 6.76 dy. Okay, so we're going to integrate that, and we get pi over 3.6 squared. We get e to the 2y over 2 plus 5.2 e to the y plus 6.76 y between h and 0. Okay, so we plug those in, so we get a volume which equals pi 3.6 squared. For h in, we get e to the 2h over 2 plus 5.2 e to the h plus 6.76 h. We put 0 in, we get take away a half and take away 5.2. So take away 5.7. Okay, now we've got to find the rate at which the water level is rising. We want the rate in centimetres per hour. Now at the moment we've got volume, which is in cubic meters. So we know okay, right, so dV by dt okay, so dV by dt, we're given as 15 litres per minute. Because the volume is in cubic meters, to be consistent, we change that. So it equals 15, and there's 1,000 litres in a cubic meter per minute. Okay, so we know dV by dt. dV by dH, we've got V, so we can find dV by dH by differentiating that, and we get pi 3.6 squared e to the 2h. We've integrated, so we get plus 5.2, sorry, e to the h plus 6.76, and we know that h is we'll get the units correct again, but h is 0.2 meters. That implies it comes out to be 3.5398 Okay, that's dV by dH, and we're actually trying to find dH by dt, the rate at which it rises. So we've got dV by dt, and that equals dV by dH times dH by dt. So the left hand side, we've got 15 over 1,000 equals 3.5399 times dH by dt. So dH by dt equals 15 over 1,000 times Okay, so this gives me an answer that's in meters per minute, because I've been working in meters and minutes. So I've got 15 over 3539.9. Remember, this is meters per minute, and I want the answer in centimeters per hour. So there's going to be 100 centimeters for each meter, and then per hour times another 60. So that should come out as being 25.4 centimeters per hour. Got to be careful on this question with the units.